Gonzalez, and with help of my partners of my team, which are Jose Eduardo Lopez, Janet Ramirez, and Giovanna Sandoval, we create this project that involves the resolution of a problem that uses many concepts that are simple harmonic motion, frequency and amplitude of a wave, and also in this project we try to find the relationship between the formulas of the simple harmonic motion and also the graphs of the sinusoidal trigonometric functions. But before we solve the problem, first we need to know the meaning of the concepts that are as I already said, the simple harmonic motion and amplitude and frequency of a wave. So first we need to know the meaning of the concept of simple harmonic motion. Well, simple harmonic motion has different uses in math, and it can serve as a math model for a variety of motions, such as the oscillation of a spring, and also in addition, other phenomena can be approximated by a simple harmonic motion, which include the motion of a simple pendulum as well as a vibration. Then we also need to know the definition of the concept of the period and also the frequency of a wave. The frequency of a wave refers to how often the particles of the medium vibrate when a wave passes through the medium through a medium. And in mathematical terms, the frequency is the number of complete vibrational cycles of a medium per a given amount of time. And also the period it refers to the period of how many time an object or something uses to achieve the objective or the time it uses to do a certain action. And finally, to end with the concepts, we finally need to know the relationship between the formulas of the simple harmonic motion and also the graphs of the sinusoidal trigonometric functions. In this relation, it can be said that the simple harmonic motion formulas and the sinusoidal functions are related. This because as the sinusoidal functions are like a normal sine function in the sense that they can be created by shifting it, stretching it, or compressing it, the same sine function, the data that use the simple harmonic motion formulas can be applied to create the sinusoidal graphs. After the period and the frequency of a wave, we also need to know what's the amplitude of a wave. Well, the amplitude of a wave refers to the maximum amount of displacement of a particle on a medium from its rest position. So in a way, the amplitude is the distance from the crest, from the rest to the crest of the wave.
In a predator-prey model, the predator population is modeled by the function y equal to 900 cosine multiplied by 2t plus 8,000.
So my team had to do the problem number 4, which states that in a predator-prey model, the predator population is modeled by the function y equals 900 of cosine 2t plus 8,000. So the problem asks us first to what is the maximum population that the predators will have, and secondly a graph, and finally the length between the successive points of maximum population. So what we have to do first? First we can start with finding our main axis, which is 8,000, because we have to move upwards in a vertical movement. Now that we have found our axis, we apply the amplitude. The amplitude is always A, so it's 900. We go 900 up and 900 down. So now we have established our boundaries or limits. So what's next? A cosine graph always starts from the top, goes to the middle, and goes to the bottom. But we forgot something very important. We haven't found our period. So how do we find our period? We know that to find our period, you have to divide 2 pi over k. So in this case, we have that k is 2 because 2 is multiplying the parentheses that is like on side. So it's equal. So that is equal to pi. Now, if we want to find the space between like points, you just divide it by 4, so it's pi. Now we know where to put the points and until when will it end or period. So we start on the top, that is 8,800. Then we will go to 8,000 on pi 4. Then we will go to 7,100. Then again to 8,000. And then again to 8,900. So with this we can already completely graph the function, and with this we can already get the two information.
Well, the answer for the first one, that is what is the maximum population, will be this, because we have the main axis will be this one, that is 8,000, plus the amplitude, that is 900. So we add them, and the result will be 8,900. That will be the maximum population of the creatures. And to find the length of time between successive periods of maximum population will be this one. Why? Well, because these are the maximum population, no? So to here and to here, how many times do we use to get there? It will be pi. So it will be pi. And we see like that t time is measured in years, so it will be pi years. One of the applications we use in real life is in music. The vibration of the strings of a guitar produce sounds that a human being hears as music. When the guitar string is plucked, it moves a certain distance, depending on how the guitar player strums. The strings return to its starting point and travels nearly the same distance in the opposite direction. The vibrational energy of the string is dissipated in the form of sound. The amplitude of the vibrations decreases gradually. The volume of the sound fades until it is eventually silenced.